Bess, and I'm the lead in the IESO project for pale blue hydrogen. We have one milestone, which is a feasibility study for the demonstration of production of pale blue hydrogen and capture of carbon dioxide by microalgae. So what we have here is an integrated system. We have an integrated system to demonstrate the feasibility of the project. The starting point is biogas, which we simulate with carbon dioxide and methane. And the first part of the project is membrane separation, which is led by Dr. Michael Mortelier. And the CO2 and methane are mixed and then separated by a membrane. The CO2 is going to an algae bioreactor. The methane goes to the plasma reactor. And in the plasma reactor, which is again the lead is Dr. Ying Zhang, who will walk you through the system. Here we have the simulated biogas. And then we go further down, we have a membrane here. We have the membranes where we are separating the CO2 and the hydrogen. And also we have recycling of methane in the plasma reactor. And then at the very end we have the small-scale algae bioreactor for demonstration purposes. And we are working on the 20,000 algae bioreactor to capture CO2 generated under the blue hydrogen project. So overall we are demonstrating effectively the feasibility of the process to generate pale blue hydrogen. This gives us blue hydrogen. We have another section where we have green hydrogen from electrolysis. And then we mix both the hydrogens together to form our net negative carbon pale blue hydrogen. It's net negative carbon for two reasons. We're capturing the carbon in the plasma reactor, and we're also capturing carbon in the algae bioreactor. It's being sequestered in bioplastic. So this is a short summary of the integrated process.
Our system uses two membrane modules. The first one, which is right here, it takes the biogas feed and it separates it into the component methane and carbon dioxide. The carbon dioxide, it diverts to the photobioreactor over there, where it gets sequestered. And the methane then gets taken at very high purity and sent to the plasma reactor. In the plasma reactor, that methane gets converted into hydrogen, and we have some unreacted methane that also comes out. We send it to this second membrane module, which extracts the hydrogen that we can send for storage and later use. And it recycles the remaining methane back through the plasma reactor so that we can get higher yield.
So this is our system and the plasma reactor system. And this is a blue trunk box is the power supply for plasma is running through the solar energy. And this is our reactor and plasma reactor. Within the plasma discharge zone, and methane is going to split up into hydrogen and pure carbon. So hydrogen is pure hydrogen, and as a product can be stored in a tank, and the carbon as the second product and is a once carbon, we can use it for either 3D printing or for electrodes. So we're currently exploring the application of this carbon right now.
Here we are in the Pale Blue Hydrogen Project, and we're looking specifically at the small-scale green hydrogen. On the larger system, we converted the power first to AC and then back to DC. We automatically lose efficiency that way. This is a much more efficient system, and it's running off of an open source DC to DC converter. Here we are at the green hydrogen portion of the Pale Blue Hydrogen Project. So this green hydrogen, we're producing 1,000 liters an hour of pure hydrogen using only the power of the solar panels floating on the pond behind me. They're providing DC power, which we're converting into three-phase industrial power to power the energy supply for an AEM electrolycyzer. Our friends at Cycloneutron have made the most efficient hydrogen generation system possible. It keeps the oxygen and the hydrogen separate, so you get high quality hydrogen. It can also handle fluctuations in the power supply, which we have because we're using the sun. And as clouds go over, it can lower down the power that it's using, and then as the clouds go away, the power increases. So we have a completely green solution for providing hydrogen at scale.